Hey there, welding wackos, McManiacs, and argon addicts. Little deviation today from our normal greeting because we're going to be talking about the Hobart today. I want to get this video in before we're due to get like a foot of snow. So I want to get out there and talk about a couple things and hopefully help you if you have bought one of these old mainliners, pipeliners. They're pretty much all designed and built the same. So let's get out there. We've got our coffee. Let's see if I can get out there and stumble over some words. Okay? This here is one of them 5-burner grill covers from Walmart. It was like 20 bucks, something like that. They work great for covering up a welding machine. So you brought one of these welding machines home. They're a strange animal. What do you do? Well, we're going to talk about it today. So guys, this is Weldy the Welder. It didn't look like this when I bought it, I'll tell you that. I spent quite a few years getting it to where it's fairly dependable. This machine isn't something that you're going to want to put on a rig and take out on the pipelines or something like that. But it's a fun little hobby. I'll tell you why you don't want to use this as a rig welder. Replacement parts are extremely hard to come by. If you're not lucky enough to find a machine for parts, some of these parts are Hobart proprietary parts. They don't make them anymore. So you have to end up making your own parts. And that kind of downtime isn't making you any money. So that being said, you bring one of these home and we're going to talk about things I think you should do first to get it running and check it out, okay? First thing you're going to want to do is pull all these brush covers. There's one here, the fan cover's here, your exciter cover is here. Pull all them covers if it has them. Sometimes I've seen them where the main brush cover is missing. Pull all them out of there, you're gonna find pieces of acorn, mouse nest, who knows what's in there. Do this before you try to run it. That's what I recommend anyways. Pull them covers off there, get all that junk out of there. Make sure there's 4 double sets of brushes underneath this cover. Make sure the brush contacts, the little pigtails are clean where they bolt on. Make sure the brushes are free. You don't have any broken springs in there. Get all the junk out of underneath the fan here. Then your main exciter, you want to do the same thing. Pull that cover, get all the mouse crap out of there. Acorns, rat nest, etc. Look for messed up wires. Stuff like that. That's what you should do first. Moving on back. Most of the Hobart machines have this kind of setup here, where you have a belt-driven governor that always wants to pull this machine up to welding speed, always. And then you have your vacuum idle control that always wants to bring it back down to idle. The way these two work with each other is how you have the machine idling right now, but whenever you strike an arc, it lets the governor take her up to welding speed, and it starts making that whoa, you know, that governor sound, that generator sound. Love that sound. Anyways, we're letting this thing warm up so I can play around with this here and show you guys. If you have one of these Hobarts and you're trying to find your way around it and figure out how everything works, I'm going to explain how this system here works after the machine warms up and we can play. Okay? Okay. Alright, I think we're warmed up enough to talk about this here. Boy, I lost my rubber. I took pieces of gas hose and stuck them on these footman loops in here. Because these covers make one hell of a racket, and boy is it irritating. So all four of these footman loops up here to hold these side panels up have gas hose around them to quiet them down. Okay, I think we can talk about this system now. I think we're warmed up enough so it'll rev up. Here's how this system works. Like I said, this vacuum idle control always wants to hold this machine at idle. Okay, it's ported off of the intake vacuum. It goes into this chamber here. Okay, let's get in here and I'll show you. It's ported off of the intake. Okay, comes into this chamber here, and it starts to add vacuum, which is governed by this idle mixture screw. Starts to add vacuum into this chamber. This is a diaphragm in here, and it pulls on this. When it builds enough vacuum, pulls her down to idle, and it holds it there. If your machine is not being held at idle, you have a mechanical problem here between the intake and this carburetor. Somewhere you have a mechanical problem where it's not building and holding vacuum here. The governor always wants to pull it up to a prescribed speed, a prescribed point. This is adjustable, and that's why you have to set your machine at 1800 RPMs, because wherever this is set is where it's going to want to pull that throttle. So if someone jacked this thing way up, well, hell, you might be welding at 2000, 2200 RPM. So this has give because this link has a spring in this, and that is letting this throttle run at idle while the governor is trying to pull it wide open. There's a spring in here that lets it do that. The way this vacuum system works is this electromagnetic coil is tied into one of your main brushes, and it goes up to one of the positions on your range switch. Whenever it senses a current draw there, whenever you strike an arc, it doesn't work when you hit on your 110 auxiliary. Whenever you strike an arc and there is a voltage drop and an amperage, it detects amperage there, I think. Don't quote me on that, but I think that's how it works. It energizes this coil. It pulls an electromagnet down on a Schrader valve on the inside of this port here. It's just a regular Schrader valve you'll see in a valve guide. Any tire has that valve guide in there. It's the same exact thing. Now, funny thing about mine is the Schrader valve that I replaced the original with was a little bit longer, so I had to shim this center part of the coil. Somehow there's like some kind of snap ring or something in there that keeps this metal core in a certain, it only has a little bit of travel. And if that's not right, like when I first got this machine, this was pressed down, the thing was always touching that Schrader valve, and it was always bleeding the vacuum off, so it would never come down to idle. Moving on to this adjustment screw here in the back of the unit. This controls how quickly engine vacuum can come back into this and bring it back down to idle. So if this is closed, this is just a regular Carter, according to the book, this is a regular Carter idle mixture screw, by the way. If this is closed completely, it will not let any vacuum into this unit, and it will never come down to idle. It will always run at welding speed. On the contrary, if this is open too much, it will build vacuum as soon as this has no more juice applied to it, and it will come back down to idle immediately. So let's say you're out there welding away, you pull up, you're getting ready to throw another rod on there, but this thing's already back down at idle. That's what this is for. I call it the dwell time, how long it takes to return to idle. So pretty simple system here. Like I say, you can't get this anymore, unlike your SA200s and stuff like that, where everything's available, and parts machines are out the ass. You can't get this stuff unless you find a junk machine somewhere, and they're getting more and more rare because, as you've noticed, it has a flathead Willys motor in it. And all the Jeep guys I know love these things because the bores are always straight. They're really good engine blocks to rebuild to put in a flat fender Jeep. So as time goes on, you're going to see less and less of these machines for sale whole, complete like this. The governor. Okay, so let's move on. You got your machine. The generator looks good. The engine looks good. Everything looks good. It runs. But you want it to do this. And when it does do this, you want to have the right voltage out here at the governor. So here's how we're gonna check this. I'm gonna cheat. I cheat twice with this linkage here. Whenever I first fire it up for the day, I unhook my governor because the governor always wants to pull it wide open and there's no vacuum there to hold it back. So before I started, I unhooked my governor linkage. And whenever I want to play and check things out, I will unhook my vacuum linkage. There we are. There are two ways. There are two ways to set this at the welding speed that is prescribed on the data plate, which is 1800 RPMs. What I did was I used a timing light with the integrated RPMs on it. Put her on there, and you will adjust the length of this link to get it to 1800. Because like I say, this governor is always going to return to a certain spot. You adjust the RPM that is with this link. So you got it at 1800 RPM, that's one way. That's assuming that your armatures and everything's clean, the brushes are good and all that stuff. There's another method to setting your welding machine at the proper RPMs, factoring in the fact that every single one of these is different. What you want to do is get it up around 1800 RPM, and then you want to start checking things. This is going to serve two purposes. One, you're going to check here for 110 DC. That's going to tell you whether your exciter is good or not, because that's where, on this machine, that's where your 110 comes from, is from the main exciter we talked about earlier, which is its own little generator. I'm not an electrical engineer. All I know is that the exciter provides current for the main generator to run the son of a gun. Anyways, and that's where you get your 110 DC. So get your voltmeter in there, adjust you're gonna check, make sure you have somewhere around 110, might be 120, might be 100, somewhere in there. Then you'll know your exciter's in good shape. Then you wanna put it on, you know, pick a current, doesn't matter, whatever. Jack her up to 100. Now you wanna measure across your main welding leads for open circuit voltage. If I am not mistaken, and I'll change it in a subtitle if I'm not right, the manual calls for 75 to 90 volts open circuit here. So some people will adjust their governor until they get it here, regardless of whether it's 1750 RPM, 1900 RPM, whatever. That's what you want, okay? So that's another way of going about setting your machine and making sure it's working right. Poop. Now you'll notice my linkage is a little funny here, and I'll explain why it's a little funny. So let's say, this is going off on a tangent, by the way. Let's say, well, I have something to grind. I want to grind. So that's what this little tang here is for. Because, ooh, that's hot. That's hot. It won't come up to welding speed when you get on the grinder, because this coil runs off the main generator. It doesn't run off the exciter. So that's what this tang is for. That's to hold it. That's your lockout to hold this up onto welding speed. And the way I made my linkage, I don't have that yet, because this is getting into a little bit of fabrication. But in order for this to work right, this has to be loose here. This basically, these two have to kind of be loose, but work on each other at the same time. I'm not exactly sure how to explain this right, but I have to fabricate something here that will let this vacuum go away completely independent from the main throttle here that the governor is acting on. Anyway, so to get around that, I just unhook the stupid thing and let it sit there whenever I want to run my grinder or something like that. They recommend with these old flatheads and this whole system here, this whole power system, if you're going to let it sit more than a month, to just drain the whole fuel system out. La-di-da, you got to use straight gasoline because it'll ruin the fuel pumps and stuff like that. You get that from the flat fender guys, which they really know their stuff about these Willys 4-cylinders. You can't run ethanol fuel them because it will corrode and destroy the fuel pumps. You can't run ethanol fuel through the Carter WO because it'll do the same thing. When I first got this machine running, it had the original 4-cylinder Carter WO that you find on the World War II Jeeps all the way up to like when the YF came out. And I ended up rebuilding that carburetor about 3 times a year because every time I would let it sit, it would jam-pack full of that ethanol corrosion. I would have to rebuild the stupid thing to get it to run again. So there was this whole big production, spending like a week getting the thing running to do a 20-minute job. Shut it down a couple months later, you're in the same boat again. So this Carter W1 that came off of a 36 Chevy has a cast iron bowl. The whole center section is cast iron. So I won't have to worry about that ethanol attacking the aluminum. So just keep that in mind if you have one of these, that you're going to be fighting with ethanol. The fuel pump was the same way. So these fuel pumps that you buy nowadays come from Taiwan or China or something like that. Omix ADA is a big supplier of these reproduction Willys parts. That fuel pump lasted about a year before it kind of crapped out on me. So I welded, machined, and fabricated a steel center section that goes on the original fuel pump housing. I will never, the only aluminum part in my entire fuel system is that sediment pool. And when that goes, it'd be really easy to manufacture one anyways. That's why I went to the custom fuel system, and if you have one of these machines, you're going to be fighting with that too. So I recommend that, yes, if you have one of these and you have the original aluminum components on there, you need to drain that fuel system off when you park the machine for any extended amount of time, or else you're going to be dealing with a jacked up carburetor and eventually a jacked up fuel pump. So that's about it for this video. I hope it was helpful. If you have any questions about this Hobart mainliner or your Hobart, like I say, I'm not an electrical expert. I mean, I have the wiring diagram, but I'm not a brainiac, okay? I'll answer the questions the best I can. For now, this is Johnny coming at you from Central Pennsylvania in Weldy the Welder. We'll see you guys next time. Thanks for watching. Hello. I changed my mind. It's not the end of the video. I'm going to let the thing run out of fuel. Get her around here to where you can pull. See what I mean? I don't like that. I don't like it running wide open when you first fire it up, especially if it's cold. So we got our fuel shut off. I am just going to crack this sediment pool and let it start to suck air. Fuel's off, and eventually it will run out of fuel. It will suck all this fuel down out of the lines from the fuel pump up to the carburetor to pump the carburetor dry. And that is how you do that. So you could do the same thing here at one of these fittings here. Get it running, shut the fuel off, crack that line right on the other side of your shutoff, and it will pump the thing mostly dry, and the rest of it will evaporate. All right? Now, for real, we'll see you guys next time. Thanks for watching. Bye.